Well, hello, HelSec. Can you hear me? I will check from my Twitch chat if I can see anyone confirming. Yes, perfect. All right, so I'm gonna talk to you about iPhone forensics today in general, and I have one real life case as well that we will follow on the on the end of each section, and that's where the actual title of this presentation comes from. And yeah, look at my title of this slide. Very unique, but yeah, you can use it if you want. So my name is Timo Miettinen, and I'm originally from Oulu region, and I studied there. Mathematician, but please don't ask me anything about mathematics. I have forgot pretty much everything. 1 + 1 is 10 or something. That's the only thing I can remember. I work at Nixu at the moment as a senior DFIR consultant. And before Nixu, I was doing some random cybersecurity, information security, IT security, whatever you want to call it, related stuff in public sector, in Finnish tax administration and Finnish defense forces. And yeah, you can find me from Twitter as well, so feel free to contact. But because this entire presentation is not about me, so let's talk about iPhones instead. So iPhone is running iOS, which used to be called iPhone OS, but nowadays actually iOS is the one running in iPhones, and iPads have iPad OS and Apple Watches, Watch OS, and so on. And the iOS is Unix-like operating system, and it's based on Darwin, which was developed by Apple some 20-something years ago, and it's based on mainly on BSD and has some code base from some other stuff as well. But actually, iOS and Mac OS are well, yeah, they have many characteristics in common, and it seems that whenever new versions come, these two actually get closer and closer to each other. And some even call the iOS Mac OS Lite. The iOS file system since 10.3, the default file system has been APFS, which is the file system in Mac OS as well. And iOS has two main partitions. There's a couple of more as well, but they're not so interesting. But the system partition, it mainly contains system artifacts, and it's mounted on the root, and it's not encrypted. And the data partition is in most of the cases the most interesting source of data, and it is actually encrypted, and it's encrypted with so-called UID key, which is burned into the hardware, and it's unique to the device, as the name says. And the files on data partition, they have actually one of these four data protection classes. Class D means that there's no, it says protection none, but it means that there's no extra protection instead of the encrypted partition. And files within class A to C, they are encrypted with file-specific keys. And this class C means that those files cannot be accessed before the user has unlocked the phone for the first time after booting it up by giving the passcode, which is the only method to unlock the phone for the first time after boot. And the class B, unless open, it means that the file cannot be accessed or actually opened if the phone is not unlocked. But when the phone is unlocked and the file is opened, it will stay accessible as long as it keeps open. And the class A means that the file can be accessed only when the phone is unlocked. And iPhones, from a forensics point of view, access to the data is protected by many layers. As we saw, the encryption is already double layered for some files, and in addition to that, the USB connectivity is also restricted, and in most of the cases, the USB is the only way to get into the phone. So that doesn't make it too easy to make forensics. And usually when talking about, for example, computer disk imaging, there's two expressions related to them. There's a logical extraction or logical acquisition. It usually means that all the files from a partition are imaged. But in iPhone context, it basically means iTunes backup plus some media files. For example, if you connect your iPhone to your laptop, you can access your photos directly. And it's good to remember when you take iTunes backup, the password protected backup contains always more data. For example, health data, browser history data. You won't find them in from the unencrypted backup. But if you are investigating a phone from a user, and the user has set the backup password previously, it is still valid, and that password will be used for all future backups as well. So always remember to ask for the user the backup password as well. But most of the cases, they have no clue. They have maybe taken the backup some years ago, or someone from company IT or whatever has actually set the password. But it's always worth asking. There's actually ways to bypass this. Actually, two ways. You can always crack the password, but the algorithm used for encrypting the backup makes the cracking really slow. So unless the password is really short or really easy to guess, it will in most cases take too much time. The backup password can also be reset, but this should always be the last thing to do, because it actually changes something on the memory, and it actually deletes some data as well. So if you have any other means to kind of bypass the previously set password, then do that. Then in disk forensics, people usually talk about physical extraction, which usually means bit by bit copy of the whole disk. But in iPhone context, there's no easy way to access the memory bit by bit, and the closest to that one is actually full file system extraction, and some tool vendors call it logical physical, or they might have some other fancy words for it, but basically that's the most complete way of getting data out of iPhone, and that always needs jailbreaking the device. Then there's one extra thing to consider. Phones back up themselves to iCloud. They synchronize data to iCloud. So if you have username and password for the user iCloud account, that's again good source for data extraction. And yeah, it can be a pain in the ass to get data out of iPhone, but there are some nice features, so to say, as well. This is how others take selfies, and this is how iPhone users take selfies. So you can always recognize if the photo is taken with iPhone, even if you don't have the metadata. And if this photo had better resolution, you could probably see the version of the phone from the back as well. Yeah, but that was the funny part. Let's get serious. So this is the case I was talking about. We received an iPhone that the original user had lost. It was later returned to the original owner by, let's say, foreign law enforcement. And the owner of the phone was kind of curious that what was done with it while it was missing. Was it stolen, or was it just inspected by friendly authorities? Yeah, when we received the phone, it was powered off. The owner didn't have any idea what iOS version it's running, and we soon realized that the passcode was set, but it was not the one that the original user had set. So obviously, at least the passcode was changed, but what else was going on? And what does this mean? So this acronym from the title of the presentation, BFU, means before first unlock. And thanks to DIST for providing me this diagram. I don't know if you actually made this yourself or stole it from the internet. I didn't have time to ask you, but thanks anyway. Okay, cool, you made it yourself. Good. Then, yeah, so basically when the device is powered on, it's called before first unlock state. The state when it boots up. And when the user unlocks it and locks the phone by locking it from the button, or the screen lock timeout goes off, then the state is called after first unlock AFU. And when the phone is unlocked and the user connects some USB dongle for it, or something to the Lightning port, the USB restricted mode is disabled. And there is 1 hour timeout for this USB restricted mode, and it starts running when the device, when the Lightning cable or something is unplugged from the device. And after 1 hour, the USB restricted mode is enabled again. Or if the phone is powered off, then of course the USB restrict mode is on again. But what does this mean? When the device is booted, the file encryption keys are wiped from the memory, and after that we can only do this quite limited BFU extraction for the device, and it means that only unencrypted and those Class D protected files are available. The biometric authentication is not possible anymore. So if you happen to have the finger of the owner of the phone in your plastic bag, you can't use that anymore. And the USB restricted mode is activated. So if you receive an iPhone that you need to investigate and it's powered on when you receive it, connect it to a power bank or something to keep it on. Then there's a couple of more things that are not so relevant anymore. They used to be in previous versions of iOS. These lockdown records. When you connect your iPhone to a computer, it asks you if you trust this computer, and if you say you trust, there is some kind of certificates exchanged, and those devices trust themselves. But and in previous versions of iOS, you could actually connect your computer to your iPhone, even if the phone was locked. But that's not available anymore. So this doesn't have that much effect nowadays. And passcode recovery attacks, at least I'm not aware of available passcode recovery attacks for the current iOS versions, but there are some from the older ones, and when the phone is on the BFU mode, the passcode recovery is much slower, but that's not a big issue nowadays. And the USB restricted mode, yeah, it was introduced in version 11.4.1 and further enhanced on version 12. And it basically means that you need Touch ID, Face ID, or passcode entry to be able to connect or activate data connection through Lightning USB or smart connector. And smart connector is the connector on the side of the iPads where you can connect, for example, keyboards and stuff. So what does this mean in our case context? So the phone was powered off and the passcode is not known. So the phone is in BFU mode. The amount of the data we can even theoretically get is really limited. And because the USB restrict mode is active, at this point we were wondering that how can we even get access to the data? And let's talk about that. Let me take a look at the, okay, yeah. Last autumn, Checkmate vulnerability and actually first exploit code were released. And Checkmate is boot ROM vulnerability, so it's unpatchable. It works for iPhones from 4S to iPhone X. It enables jailbreaks, activation lock bypass, and stuff like that. And a couple of months later, Checkrain jailbreak was released. And jailbreaking is basically privilege escalation for basically any Apple device, but in this case for iPhones. And Checkrain utilizes Checkmate exploit to run unsigned code. It officially supports iPhones from 5S to X and iOS versions 12.3 onwards, but at least I've managed to run it on iPhone, which had iOS 12.2, but so this is not so accurate. And people have noticed that on some cases, when running the Checkrain jailbreak, it actually bypasses the USB restricted mode, but not every time. And this seems to be related to the combination of hardware and software versions. And I have tried this with iPhone 6s running iOS 12.2. It didn't bypass it. I wasn't able to connect any device for it, but then with iPhone 7 and iOS 13.2, it actually bypasses it. So I'm able to SSH into my test phone, which is iPhone 7, which is interesting. But some open source / free tools you can use. So basically Checkrain to do the jailbreak. And if you want to get the biggest amount of data that is available, then you always should do the jailbreak, unless you're not allowed to do it or you have an iPhone version that has no working jailbreak. And then if you don't have the BFU restriction and you can't jailbreak the device, you can always use iTunes to get the backup. And for some quick triage, you can use tools from Lib iMobile device, which has collections of useful tools. iDevice info, for example, gives you quickly the iOS and hardware versions. And then one quite nice, it's actually a script utilizing some other tools on the background, is this iOS BFU triage. it utilizes, for example, these lib-iMobile device tools. And then if you're not lacking money, here's a list of commercial tools just for your reference. I'm not going to go that deep into these. So our case, we did the jailbreaking for the device with the checkra, but the USB restricted mode was activated after reboot, and because we didn't have the passcode, no luck. But some of the commercial tools have recently implemented their own ways to bypass the USB restricted mode when utilizing the checkra jailbreak. They have added some extra code to the jailbreak. So one of the tools we use got an update, and we finally managed to extract some data out of the phone. But yeah, life is not always easy. This particular product has basically two parts. One for the extraction of the data and one for doing the analysis. And the analysis part of the software didn't manage to open to archive the acquisition part created. And I checked this with later versions as well, and it still fails, which is pretty weird. But so what the fuck? Let's do the analysis manually then. Which is, by the way, a good idea always to look at the data manually, even if the tools are working. They are not perfect. iOS is constantly changing the structure of the data changes, and it might take a while for the tools to catch up those changes. And then again, if there is some not so popular apps installed on the device, for example, those tools don't have any clue what kind of data they are storing, and they can't parse it. So it's always a good idea to check the data manually. So the analysis part. Yeah, most of the interesting data can be found from text files, which can be logs or something else, plist files, which we will talk about in a minute. There's databases, and then of course media files. And yeah, Apple products and timestamps can be a bit confusing sometimes. There's at least 3 different epoch times available for you, so good luck. So if you need to work with epoch timestamps, then it's better to use some kind of tool that converts it to date with many different, using many different formats, so you can see them all at once and pick the most probable one. And in installation logs, yeah, Cupertino time zone is used until the real time zone is actually set for the device. So if you take a look at the installation logs, and the installation is done in Finland, for example, at at some point you will actually see just a jump of I don't know how many hours, 9-10 hours ahead for the timestamps, and you might be wondering that what the fuck is going on here if you don't know this. Yeah, some open source / free tools you can use for the analysis part. Apollo is yeah, it basically parses the what has the user been doing while carrying the phone, and yeah, it parses the data and outputs it in the human readable format. Then iOS sysdiagnose forensic scripts, they are really good on parsing the sysdiagnose logs. Then if you have iPhone backup, this iPhone backup analyzer can be used to browse the content. iLeap, or however you say it, this actually reads data from really many different files across the file system and tries to parse, for example, yeah, basic information about the device and the user and the installed applications and yeah, stuff like that. Another iPhone backup viewer, then couple of tools that we will take a look at shortly in a couple of slides as well. But F3, it basically crawls the directory structure and gets data structures from the files. And deserializer converts these specific kinds of plist files to normal plist files to make them easier to read. And plist, property list, is where the name comes from. You can find them all over the file system. The extension may be plist, or it can be something else. Apple doesn't seem to care. It has a couple of formats, XML, binary, and then this special structure of NS-keyed archive. And here's an example of XML plist. Well, yeah, it's XML, easy to recognize. I don't like to read XML, so I usually use plutil to actually output it into this format, which is much nicer to read, at least I think so. Binary plist, yeah, file signature, Bravo, Papa Lima, India, Sierra Tango, 00, easy to recognize as well. And these can be made easier to read with this same application or tool, plutil. And there's also Python library, plistlib, that you can use. It works with XML and binary plists. Then plists may contain another plists. Here, for example, this object called CloudKit persisted state, and the value is hex string of binary plist. If you check the first few bytes, you can easily see it. Yeah, you can use plutil and xxd to actually extract the data and then print it out in this format. This looks horrible and might be that I'm just stupid, but this is still the easiest way that I have managed to do it. And when you take a look at the output, it says on the first row, NS-keyed archiver. And this is not, again, quite, well, very easy to read. For example, if you take a look at the events were removed from event kit key, in the end it says value equals to 2. This doesn't actually mean that the value is 2, but the value is found from object 2. So basically you have to go to object 2 and see that the value is 1. So pretty complicated. But oh fuck. So there is this deserializer script that you can use to convert these NS-keyed archiver plists to normal ones, and now it's again much easier to read. SQLite databases you can find quite often. If you move them around to analyze them on different location, always check if they have these SHN and WAL files on the same directory as the actual database, and remember to move all the 3 to the location where you want to do the analysis, because those 3 together actually contain the whole data. One SQLite database browser I like to use. And the blobs in the database can actually contain binary plist files again. And you might want to extract them. You can use SQLite 3 to actually dump all the data from the database to one text file. But the blobs are as hex strings in this case, and we will see how to deal with them. Then if you find a binary, or actually you usually see it as a hex string or a binary file that doesn't make any sense to you, they might be protocol buffers. Some applications are using these more and more nowadays. It's worth trying out these Google protobuf utilities to, if you can decode the data. If not, it's something else, but it's maybe worth a try. Yeah, so tools find most of the interesting data, but not all. And since we had we didn't have that much data available, so we wanted to get everything out of the data that we had. I wrote a script that basically first runs the F3 against all the files and gets data structures from each file, so I can see if the plist contains another plist, or a database has a plist inside of it. Then it dumps all text files as is. It converts all plist files to readable format, dumps data from every database. Then it gets all embedded binary plists from plist files and databases and converts them to readable format. And it outputs everything on one directory where I can start grepping, basically. And yeah, if the script does what it's meant to do, but it's not very pretty at the moment. If you are interested in the script and you would like to use it, please let me know. I will clean up it a bit and I can publish it as well, but it's not in a condition to be published at the moment. But let me know if you're interested. I can work for it. So what we actually found from the phone, yeah, the host name, computer name, a username of the, we found out that the phone was reinstalled quite soon after it was lost from the original owner. So the username or Apple ID of the new owner of the phone was found. The installation timestamp, and then we searched for all timestamps and took the latest, and we had kind of a window of time when the phone was used. Well, basically version information, hardware and software, the language settings. Then this particular file here actually contains information of accounts that were contacted with iPhone's internal communications apps. So basically FaceTime, iMessage, stuff like that. And when user makes a connection to another iPhone user or any other Apple device, basically, the Apple ID of the other user is validated from Apple servers, and there is an entry written into this file, and it contains the contact information, so basically the Apple ID as a phone number or email, and then timestamp. So it basically gives pretty good idea about the calls and SMSs that has been going on between user of this phone and other Apple device users. Then a list of installed applications, and including the arrangements of the icons on the home screens. Then iPhone keeps tracks on Wi-Fi networks it's being connected to, and you can find the BSSID of these networks, which then can be resolved to geolocation. Then the new user had installed this Sberbank mobile app, and it obviously utilizes Yandex metrics, which is kind of Yandex equivalent to Google Analytics. And it had also stored some location information in a file that was not protected by file key, which is probably not a good idea. And then again, this Sberbank mobile app stores all the push notifications it had showed for the user. And for example, whenever the user had used his credit card, it pops up a push notification, just like, for example, Nordea Wallet and many others, I guess. But all that information can be found also from the disk, and basically it gives timestamp and name of the store where the card was used, but luckily not the whole card number or any other information. But still, you can use that to figure out what the user has been doing with the phone. Yeah, so basically the device was reinstalled quite soon after it was lost, and the applications installed gives quite good hint that it was basically a normal user that was using the phone. The device was used to communicate with several contacts, and the device was used around the city where it was actually lost. So most likely it was just stolen and reinstalled for use. And some reading for you if you are interested in mobile forensics or iPhone forensics in particular. Some nice people to follow on Twitter and their blogs. And I think I passed my 45 minutes with a couple of minutes, but that pretty much concludes my presentation. So Juho, was there?
Yeah.
Questions?
Thank you very much. Thank you very much, Timo. That was entertaining talk and really good one. So we have a few questions for you.
Yep.
Actually, kind of many of them. Let me see.
All right.
Here we go. So the first one, it's from Nora on Twitch about your shirt. What's the and your actually presentation start where you were telling about yourself. So the question is, what's that number you are wearing?
What's the number I'm wearing? Okay,
next one.
Okay, next one.
So the Tommy B asked on the Discord that what protections need to be bypassed to extract an iOS backup from iCloud?
Well, yeah. Usually, you need to know the Apple ID and the password, and then it most likely sends the verification code to the phone as well. So you basically need all those three.
All right. Ladybug is asking, is it still true that iPhone 11 does not have known vulnerabilities leading to a jailbreak?
At least I'm not aware of any. Yeah.
All right. Jay is asking, can the iPhone that has gone through forensics be used after, or should the user just get a new device?
It can be used, yeah. And especially if we do the extraction with one of those commercial tools, they are built so that they should leave, at least they claim that they leave no traces to the phone, but who knows? There might be some, but yeah, but yes, you can use the phone basically afterwards if you want.
All right. Any idea what happened in the end of the San Bernardino shooter's iPhone 5C when the Apple denied request for uncoding? Supposedly an InfoSec firm got access in the end. I think it was some company from Israel, right? Or do you know what happened there?
I can't remember this specific case and the details of it, but I can take a look at it and post some links later on the Discord for it.
Yeah, perfect. Because there was also a question about the links you have on the slides. Could you somehow provide them to the audience as well?
Yes, I can.
Yes, that's cool. Then there is questions about the acquisition tool you used or the software. Was it the same software company that you used for acquisition and analysis?
Yes, or well, we tried, but as I said, it didn't understand its own format. So we basically had to do the analysis manually, going through the files that we already knew contain some interesting information, and then dumping everything to one directory and then started grepping with words of interest.
Yeah. grep is a really good forensic tool for everyone. I highly recommend it as well.
I totally agree with you.
Yes,
totally
thank you very much, Timo, my friend, comrade. One more question. There is actually more, and if you could answer them on the Discord, because we don't have much time anymore. But I will ask one more question, and it is from Hetti. It's about do you contribute back to the open source software if you, for example, implement something for your work?
Yes, if, but I mainly have been only using the stuff so far. But for example, this script I mentioned earlier, I'm planning to publish it whenever I have time to rewrite it in Python, as you Juha told me to do in the beginning, but I didn't believe you. So I think I need to actually rewrite.
You mean the bash script you were working?
Yes,
it was like a fucking horrible spaghetti.
Yes, that one. Yes.
All right. So, but you will probably do it, and also I can tell here that we at Nixu try to do so, but sometimes we can, sometimes we don't. For example, in the this Netscaler's case, there was this addition to the volatility where you can actually analyze the Netscaler images. So some stuff end up to the public internet. But yeah, Timo will answer the questions. The questions you asked that we didn't have time to go through on the Discord. But we will move on to the next talk, and it will be from the motherfucking Johoi from Turku. So stay tuned, and we will back in a few minutes.
All right. Thank you.